We should be on page 9. Page 9 at the top of the page should say 1.2 variables and expressions. All right, the first thing you need to know is some vocabulary. Some vocabulary, fun stuff. All right, 3 different terms that you need to know. We're going to use all 3 of these terms throughout the year, so it's important that you become familiar with them. The first one is a variable. A variable is a letter that is used to represent a number. You need to be writing these in your notes, okay? All right, a letter that is used to represent a number. So that's any letter, A through Z. I can use that letter to represent any value that I want to give it. A variable expression can have a number in it. It can have a variable, but it always has an operation. That's what makes it an expression, okay? So you'll see right here in this example, the operation, okay, the operation is an addition sign. That's what makes it an expression, n plus 6. And then the third term you need to know is to evaluate, okay? What I mean when I say evaluate is substitute the value for the variable and simplify. Basically, to solve it, okay? So if I say evaluate this expression, I mean to simplify it as much as possible. Substitute the value for the variable and then simplify. Now let's get into example 1. All right, so in your notes, example 1. All right, example 1 you should write in your notes, and let's evaluate some variable expressions. The first one says evaluate x plus 4 when x equals 9. All right, so it gives me a value. All right, we have the term evaluate that we just learned what that means. Substitute the value for the variable and solve. All right, so in your notes, we're just going to get in the habit of writing the original problem, the substitution, and boxing our answer. This is what I'll expect on your homework tonight. All right, so we have x plus 4 as the original problem. We make our substitution. 9 substitutes for x. And then 9 plus 4 is 13. And we box our answer. Now in the second one, we have a subtraction problem, or a subtraction expression, but it's the same concept as the first one. All right, so we make our substitution. Y minus 3 as the original problem. Make our substitution. 7 substitutes in for y. 7 minus 3 equals 4. In example 2, still the same concept. We're substituting the value for the variable and solving, but now we're dealing with multiplication and division, okay? So let's look at the first one. It says evaluate 4n when n equals 6. So again, we're just going to get in the habit of writing the original problem, 4n. Now, does anybody know what operation is represented by a variable and a number together? What operation is that, Zach? It's multiplication, okay? So if you don't see anything else in between, it's multiplication. 4n when n equals 6. Now, when I make my substitution, I'm going to use parentheses to show the multiplication. Can anybody tell me why I am not going to use a little x to show multiplication? All right, so if I see that little x and you're showing multiplication, I'm going to take points off. Why? Justin?
Because x stands as a variable.
Because x can be a variable too. So if I use x for multiplication, it can be confusing, okay? So no little x's and no dots to show multiplication. I want to see parentheses on your homework, okay? Good? All right, so 4 times 6 is, class? 24. Class? All right, there we go, 24, and box your answer. All right, now in the next one, z divided by 2 when z equals 8. Again, original problem. Make your substitution. And what's 8 divided by 2, class? 4. Very good. Remember, 8 over 2 as a fraction is the same thing as 8 divided by 2. Numerator divided by the denominator. And we get 4. All right. All right, now let's talk about example 3, evaluating expressions with 2 variables. Now, I was a little more generous tonight on your homework than I realized I was, so you actually don't have any of the example 3 problems on your homework, But it doesn't mean you're not going to see this on a quiz or a test, because you might, all right? So let's go through this together. Evaluating the expressions with two variables. Now, in this one, it's a word problem. It says evaluate the expression G plus A when G equals number of goals and A equals number of assists. Let me ask you this. Why did they choose G and A as variables? Why not A and B? Why not X and Y? Why G and A? What do you think, Justin?
Because variables can be anything, any number.
Okay, variables.
I mean, not any number, but any sign.
Yeah, variables can be any letter, so why did they choose G and A? Why not some other letter? Daniel?
Because G stands for goals and A stands for assists.
Yeah, because practically speaking, okay, G I can connect with goals and A with assists, so it makes sense, okay, it's logical. So it asks us to find the number of points earned by a hockey player with 12 goals and 29 assists. So let me ask you this. 12, we would substitute in for what variable? G or A? G, right? Because it was 12 goals, I'm going to plug in 12 for G, and then I'll plug in 29 for A. Very good. Okay, so here's our original expression. G plus A, that's our variable expression. And now I'm going to make my substitutions. 12 substitutes in for G, and 29 substitutes for A. When I add them together, I get 41. Anybody know what the label would be?
Goals and assists.
Not quite. What would it be?
Points are
Points. Very good. Points. 41 points total. All right. So whenever you're dealing with two variables, it's the same thing as if you just had one, except now you're just making two substitutions instead of one. All right. And if you understand that, that's everything you need to know for 1.2.